This is APAB Calc. We are doing limits from tables, which is more of 1.2 after doing limits graphically. I incorrectly said that algebraically would be next. That's actually 1.3. So when we have a calculator or a table that's given to us with numbers, which we'll talk about in a sec, we can evaluate a limit using a crazy table. I'm going to point out ahead of time that this is tedious and annoying. We're going to walk through it quickly because you're going to learn better options in 1.3. I would literally never pick this option, ever, under any circumstances, unless I were forced to do so. So because this is the kind of question that you might see as like a crazy multiple choice or something, who knows, right? I want to walk you through the logic of how this works. Okay, so notice that what I'm doing here is evaluating the limit as x approaches 2, right, by filling out these values. So what I want you to notice is the values that were given to me in this table, and I did write this table, but I wrote it specifically because these will be the values that are given to you if like an AP asks a question like this. What I want you to notice is that right here would be 2, right? Oh, sorry, that I just replaced this with a good marker and I grabbed the wrong marker. So right here would be 2, okay? So meaning, if you notice, these values are getting closer and closer to 2 progressively. So what's happening here is we are approaching 2 from the left, right? And if you look at these values over here, see how they're getting smaller and closer to 2, right? So these are approaching 2 from the right. So what's happening, so approaching 2, so x equals 2 or x equals 2, from the right, okay? So what's happening is we can use these numbers to figure out what the right-sided limit is and what the left-sided limit is and see what those two numbers are. And if they're equal, then just like we saw graphically, we get a numerical value for the double-sided limit. So essentially what's happening is what number these guys are approaching is going to give you your left-sided limit, and what number these guys are approaching as you approach from the right is going to give you your right-sided limit. And then if those two numbers are not the same, your answer would be D and E. And if those two numbers are the same, then your answer would be whatever number you get. So when you go to plug this into your calculator, it's no fun. I'm going to own that right away, right? So when you go to plug this into your calculator, I would suggest, and you don't have to do this, but I would suggest that you go to your y equals, clear out everything there. I'm going to type in this whole thing. So 2x minus 4 in parentheses divided by, in parentheses, an x squared minus 4. So I'm going to type that whole thing in like that in my y1. And then what I'm going to do is I'm going to go to table set. So second window gives me table set. And I'm going to start my table at 2. Okay, so this is a little clever trick. 2 being the center, because that's the thing I'm approaching. So what I'm then going to do is I'm gonna make my table go by 0.1s. Because from 2, if I go 0.1 in either direction, it'll give me these two first spots. So I'm going to make my table go by 0.1. So see what I did is I started at 2, and then I made it go by 0.1. So now when I go to second table, which is second graph, oh, sorry, I missed a 4 when I typed in my function, which it just caught me on syntax. So it's an x squared minus 4, my bad. So I go to second table. Now here's what you're going to notice. There's going to be an error at 2. That's why I need to use the calculator. I'm not able to just see what number comes in when I plug in. But what you'll notice is if I scroll up a second, you'll see I have both 1.9 and 2.1 on my calculator. So 1.9 was 0.51282, and 2.1 was 0.4878. Okay. So now I'm going to go back to table set. So again, this is just a trick, having done this problem a lot of times. I'm going to set my table to start back at 2. And now I'm going to go by 0.01 because that'll get these two. And now I go back to table, scroll up 1, and now you'll see that I conveniently have both of those values. So 0.199 is a 0.50125, and 2.01 is a 0.49875. Right, and then I'm going to go back to table set. I'm going to start it back at 2, and now I'm going to go by 0.001, right, just like that. All right, and then I hit enter, go ahead and go to my second table, and then you'll see my table value. So I get 0.50013, and this is a 0.49988. So it's pretty clear that from this direction, these values are approaching a 0.5, right? They're getting closer and closer to 0.5. And it's pretty clear that from this direction, these values are also approaching a 0.5. So this limit, right, the value of this double-sided limit, right, so the right-sided limit is a 0.5. The left-sided limit, as I approach from the left, is also a 0.5. So my answer is that this limit, when I'm asked to evaluate that limit, it's equal to a 0.5, right? And you're going to figure out how to do that by hand, which I think is by far the better option in 1.3, which is our next section. Now, again, I would never, ever, 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 ever pick this option. It's tedious, it's frustrating. The only time to do it is if you're expressly given a problem where they say, hey, here's this table, fill it out and answer what the limit is. And if I weren't asked to expressly fill this table out, I wouldn't do so. Sometimes you'll see an AP problem where they give you multiple choice, and they'd say, hey, what could this table be showing you? And you would point out that it's showing you the limit as x approaches 2, right, of this function. So there, it wouldn't be the limit as x approaches, let's say, 0.5, because x isn't approaching 0.5, right? X is approaching 2. So I'm going to give you a P2 rather to try that's similar. Again, don't stress too much about this. It's tedious and frustrating. If you see one like this, it's best to be able to recognize that this is giving you a limit as x approaches 2, because you look at this middle value and say, oh, these guys are both getting closer to that 2 of this particular function, right? And it's good to be able to read the table and see what the output is. So I'm going to give you one where you plug it into the calculator. It's a little bit tedious, but you'll survive. So what I'm going to do is I'm going to erase, so same skill, but rather than have to recopy this entire crazy table, all right, let's pick a different function. So for a P2, and let's not make it 2. Okay, so now these are all 5s, okay? So now the number that we're approaching is 5, right? We're approaching 5 from the left and 5 from the right, 5 from the left, 5 from the right. So let's do the limit as x approaches 5 of, let's do x squared minus 4x minus 5 over x squared minus 25. Okay, so what you're going to do is and I'm actually just going to call this thing f of x for my table because that's easier. So f of x. All right. So we're going to do the limit as x approaches 5. Notice how these numbers get closer and closer to 5. And the lazy, easy way to do that is if you want 5, you pick the number right below 5, which is a 4, and you do 4.9, then 4.99, then 4.999, and so on, right? And then you pick 5, and you do 5.01, 5.0, 5.001, 5.01, 5.1. So if you want to pause me, you can pause me, right? We're going to go ahead and do this the exact same way. Again, if you want to pause me, go ahead and pause me, okay? So I'm going to type into my calculator, and I'm basically just going to type over the y1 I already had, right? I'm going to type in x squared minus 20, and I'm going to second insert to get the 5 in there, right? And on the bottom, I have an x squared minus a 4x minus 5, right? So I type that into my calculator, and then I'm going to use that trick. I'm going to go to table set, and I'm going to start my table. So second table set, I'm going to start my table at 5, and I'm going to go by 0.1s, right? And that's going to get these two, and then 0.01 will get these two, and then 0.001 will get these two. Again, you don't have to use that trick, but it just makes it a lot faster. Cool. So that's a slightly not awesome number, but you'll survive. Okay. So when I do 4.9, I get 1.678, right? And when I do 5.1, I get 1.6557, right? And then I'm going to go back to my table set. I'm going to go back to starting at 5. I'm going to go by 0.01s and go back to table. This is a 1.6678. This is a 1.6656. Second table set, I go back to starting at 5. I do 0.001. Second table set. Cool. I get that this is a 1.6668. This is a 1.6666, right? So what it's seeming to look like, right? It's definitely starting to look like this is going to be essentially a 1 2/3 repeating, right, or a 5/3. And I can confirm. Let's see, x minus 5, x plus is, that's a 6. Hang on. I think that if we did this, x plus plus 5x minus 5. I should get a 6. I get a 10 on the top over 6 is 5/3. Hey, yes. Okay, so it should be 5/3. So, sorry, my brain, it's late and I'm tired. So, anyway, so sure enough, if you keep going, you're essentially going to get this is a 1.6 repeating, right? So this answer ends up being a 5/3. And I can confirm algebraically that it is actually a 10 over 6, which is a 5/3. And you'll learn how to do it algebraically again in 1.3. So I should have picked a slightly nicer one that gives you a number where you didn't have to kind of figure it out, but this is a 1.6 repeating. All right, so let's walk through one more example. So I think that you're not likely to see this on an AP exam where you have to generate the table yourself, just to be perfectly honest. So let's talk about E3. I think the way you're more likely to see this on an AP exam is a situation where they give you a table. Right? So I think you're more likely to see something like x and f of x, right? And let's do 1.001, 1.01, 1.1, 0.999, 0.99, 0.9. Okay. And let's say let's do 3.1, 3.02, 3.001. Great, okay. And then on this side, let's do negative 2.3, negative 2.005, negative 2.0001. Sure, made up numbers. Great. Okay. So I think they're more likely to give you a table like this and then ask you to evaluate the following. Like to ask you, what is the limit as x approaches 1 from the left? What is the limit as x approaches 1 from the right? What is the limit as x approaches 1, right, for each of those for f of x? I think they're more likely to give it to you where you're given a table. I can't imagine that on an actual advanced placement exam, they want you to do this crazy tedious thing of entering limit stuff into a calculator to find values. So the left-sided limit, so we can hopefully agree that this is where 1 would live, right? These numbers are getting closer and closer to 1 from the left-hand side, right? So this is from the left, and this direction would be from the right, right? So from the left, it would seem that these numbers are getting really close to 3. That's the value I think that they are approaching from the left. From the right, it would seem that these numbers are getting closer and closer to negative 2, which means that my double-sided limit would not exist, right? Because those are not the same number. They're not approaching the same value. So I think that's the way you're more likely to see it on an AP exam. I can't know for sure. I also think instead of seeing it like this, you might see it as multiple choice, right? So they could say which are true based on the table, right? And they could say something like that where they say 1, they could say something like this, like 1, the limit as x approaches 1 from the left of f of x is 3. 2, the limit as x approaches 1 from the right of f of x is 1. 3, the limit as x approaches 1 of f of x is a negative 2, right? And then they'd give you that situation where like A was 1 only, and B was 1 and 2 only, and C was 2 and 3 only, right? And D is 2 only, and E is none or something, right? So they might give you this multiple choice situation. Now we know that this one's true, and we know that this one would be false, and this one would also be false, so the answer would be 1 only. But that's the way I expect that you'd see it on an AP. I cannot imagine that they would actually spend the amount of time to make you fill out a stupid table. It's not testing your actual knowledge, it's just testing your ability to use a calculator, which is, not even using a calculator for an impressive scale, right? It's just typey, typey, type. It's miserable. So anyway, so if you were to see one like this, that's how I'd expect you to see it. I wouldn't expect you to see it in any other way. So I'm not going to do a P3 like that. I just want to kind of show you what I would expect you to see that as if you were going to see it on an AP. So that's kind of the